Hey, fifth grade. You ready for math? Let's do it. You'll notice I'm at a different place. I had to come to my husband's office while we were having our house sprayed for ticks. It's terrible. But hopefully the pest control people are going to take care of it. And we got Eloise on some really strong medicine. So anyway, I just wanted to say hi again, and I'm going to put Dobby on. You need to take out your notes that say problem set 115, and we're going to go through problem set 115 and 116 in this session. I've got to be faster. YouTube got mad at me. My video last time was too long, took too long to upload, so we're going to blow through this kind of quickly. If it's too fast, go back and rewatch, go back and read the lesson. Do the practice problems. Do what you need to do to get understanding. Email me with questions. If we need to set up an appointment time so that you and I can video chat or even talk on the phone, we can do that. Okay, we can make this work. All right. See you in. Well, plug in Dobby. Let's do this. Okie dokie. Adding and subtracting mixed measures. Problem set 115. So we're going to come across problems where we are going to be talking about feet plus inches or hours plus minutes. And how do we handle that? And oh my goodness. Sorry about that. Had to get my pen. So measurements that include more than one unit of measurement are mixed measures. If we say that a movie that you would watch is an hour and 40 minutes long, we're mixing hours and minutes together. When adding and subtracting mixed measures, we might need to convert one unit to another unit. So it might make it simpler to convert the hours to minutes, so we can just be working with minutes. Or this is example 1 right here. Let's look at this one. 1 hour and 40 minutes plus an hour and 50 minutes. When we add 40 and 50 minutes, their sum equals 90 minutes. And we know just by looking at this, an hour is 60 minutes, so 90 minutes goes above an hour. So if we were going to just do the simple addition here, we would say 90 minutes, 2 hours. So our movie totals 2 hours and 90 minutes. Well, we need to convert this because 90 minutes has an hour in it. We need to pull those 60 minutes out of that. So when we do that, we take 90 minutes, we take an hour out of it, leaves us 30 minutes, but we have to add that hour over here. So now our 2 hours becomes 3 hours. And because we took 60 minutes out of that 90 minutes, now we have 30 minutes. So it's just one of those problems that requires a couple steps. Let's subtract feet and inches. First, we need to just kind of do a quick little memory jog. How many inches are in a foot? Oh yeah, 12. Okay, right. I'm going to need that information later. So first I'm going to start with 5 minus 8 inches. Uh-oh, I've hit a snag. 5 inches is not big enough to subtract 8 from, so I need to go and borrow. So I'm going to borrow a foot. But this is where it's helpful to remember, how many inches are in a foot? I can't just come over here and say 1 foot 5 inches. I need to now add 12 inches to our 5 inches so that we can have a proper subtraction problem. So now I've got 17 inches to subtract 8 from. And that's doable, right? Because 17 is more than 8. So 17 minus 8 is going to give us 9 inches. And now we're going to come over here to our feet. 5 feet minus 4 feet is going to give us 1 foot. And there's nothing we need to do. This isn't over 12. If it was over 12, we would need to add a foot over here. But since it's not, we've got our answer is 1 foot 9 inches. Okay, if you have questions about how to do that, again, go back and rewatch or go look in your book and read over those example problems. But I do want you to take a minute to pause this video. I want you to work out the practice problems in the next box. And so pause it and come back to me. All right, quickly, I'm going to go over those practice problems. I want to make sure, but if you haven't done it, pause it and do them. Okay, I'm very serious. Now, let's look over them and see if you got the right answers. And if not, let's talk through why. So when we add 5 plus 8, you got 13 inches. 6 plus 4 is 10 feet. So 10 feet plus 13 inches that's where we start, but then there's a second step. Because this exceeds 12 inches, that means there's a whole foot in that inches. We need to get the foot out and put it in the foot column. So by doing that, we have to take out 12 inches and add it over here to the foot side. So that gives us our answer is 11 feet 1 inch. So if you got 10 feet 13 inches, you need to go one step further and get it all the way converted. And then the other one, the answer is 1 hour and 35 minutes. You needed to borrow 60 minutes from this 3 hours right here, which gave you 75 minutes. 75 minutes minus 40 gives you 35 minutes. And then because you borrowed, you now have 2 hours instead of 3. 2 minus 1 is 1 hour. There's nothing more that you do here because this isn't more than 60, so we don't need to take anything out of it. It's good at 1 hour and 35 minutes. Okay? Give me a thumb if you've got it. If not, go back and watch the video again. Read the lesson. Email me. Ask a parent. Okay, lesson 116. Oh, I'm sorry. Actually, there's more to 115. Multiplying by powers of 10. So this is kind of what we've already talked about. We've talked about how to multiply decimals by 10 or by 100 or by 1,000. But this is taking numbers with powers of 10. Now, what I want you to do right now is I want you to take your pencil and add a square to this 10. You know, I can't do that on my computer. And then we're going to add 1.2 times 10 to the third. Okay, just go and add that those little exponents, the 2 and the 3 right there. So we can multiply by powers of 10 very easily. Multiplying by powers of 10 does not change the digits, only the place value of the digits. So it's kind of easy. We're not changing numbers. Their numbers are going to stay the same. We're just moving decimals, adding zeros. We can change the place value by moving the decimal point, the number of places shown by the exponent. So if we had 1.2 times 10 to the third power, we're going to write that in standard notation. I look at this exponent right here. I'm going to move my decimal 3 places over. My number is going to get bigger, so I move my decimal to the right. So I've got 1.2, sorry, ignore that. 1, 2, 3. So our new answer is 1,200. If we are writing that in standard notation. Let's take the number 6.2 times 10 squared. So I've got my 6.2 here. I'm looking at my exponent. My exponent is 2, so I'm going to move my decimal over 2 places. 1, 2. Okay, fill in with a 0. So my answer is 620. All right, well, what do I do with this? It says to write 500 million in standard notation. Well, the first thing we need to do is we need to get this half right here. We need to put that in a decimal. So we know that half is the same as 0.5. And now we're going to multiply it by 1 billion. And 1 billion it's got a lot of zeros. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So when we write 500 million, sometimes powers of 10 are named with words instead of numbers. So for example, we might read that there are 5.2 million people living in Hong Kong. Well, the number 5.2 million means 5.2 times 1 million. So we would just write that number by shifting the decimal over 6 places. And in this case, if we're going to write 500 million in standard notation, we would move our decimal over. We're going to count up the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got our 0.5. We're going to move it over 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. And fill in with zeros. 1, 2, 3, comma, 1, 2, 3, comma. So 500 million is half of a billion. You see that? All right, take a minute and do your practice set. Down here, fill out this box. Before you do that, I want you to add in exponents for me. So we're going to add, so pick up your pencil right now and add these exponents. 1.2 times 10 to the 4th power in standard notation. And the other ones are good to go. Let's do one more of these, like at 1/2 a million. So if we were going to do 1.5, that's the same as saying 1.5 times 1 million. So we're going to count our third zeros, 1, 2, 3, 4, 5, 6. So we're going to move it to 6 places. 0.5, 1, 2, 3, 4, 5, 6. The dot, and then go in and fill up our zeros. Comma, 1, 2, 3, comma. So 1,500,000. And yeah, I want you to do the others on your own. Pause it and come back to me and I'll show you, we'll make sure you got the right answers. See ya. Giving you a minute. I don't want you to see the answers yet. Have you done them? Okay. So the first one, 4 is our exponent. We're moving our decimal over 4 places. It should give you 12,000. We did that. We did this one together. We changed 2.5 billion into a decimal, 2.5, and then you multiply that by 1 billion. And that would give you, move your, you're going to move your decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill up our zeros. That 2, 1, 2, 3, comma, 1, 2, 3, comma, 2,500,000,000, something crazy like that. And then what do you do with this? You take 250,000, you put that into a decimal. Your decimal is 0.25. If you haven't done that step, that might be what you're stuck on. 0.25 times 1 million. We'll look at that. We're going to move our decimal over 6 places. 0.25. 1, 2, 3, 4, 5, 6. Boop, 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 boop. 1, 2, 3, comma. 250,000 is 1/4 of a million. Usually it's about money. Sometimes it's about people. Okay, find this blank box. Let's move on to problem set 116. Titled Unit Multipliers, and just sit tight for just a minute. You don't need to write anything. You don't need to doodle or draw. Just listen. A unit multiplier is a fraction equal to 1 written with 2 different units of measure. Recall that when the numerator and denominator of a fraction are equal, meaning the same, so if the top and the bottom is the same, we know that that equals 1 whole, don't we? The fraction equals 1. Since 1 foot equals 12 inches, we can form 2 unit multipliers using 1 foot and 12 inches. So we could say 1 foot over 12 inches, that's going to equal 1. Or we could flip it. 12 inches over 1 foot is going to equal 1. Each of these fractions equals 1 because the numerator and denominator of each fraction are equal. So unit multipliers help us. They help us convert from one unit of measure to another. If we want to convert 60 inches to feet, we may multiply 60 inches in the unit multiplier and we can figure out by reducing down 1, 5 times 1. Oh, and we cross out our inches here. We cross out inches and inches there, and now we've got 5. What we have left is feet. So our answer is 5 feet. Come here, Louise. Next one I want to look at is write 2 unit multipliers using these equivalent measures. So if we looked at the equivalent measures are 3 feet equals 1 yard. So when let's go back up here and look at what a unit multiplier is. We could make 2 out of this equation with equals 1 yard. Or we could say 1 yard and 30 feet. These both equal 1. Right? See that? The units we change from are in the denominator. The units we change to are in the numerator. So you do have to look at what the problem is asking. The unit we change from is in the denominator, and the unit we change to is in the numerator. So to convert 30 yards to feet, we use the unit multiplier that has the 1 yard as the denominator. And the 3 feet at the top. So we're going to cross out, we're going to cross cancel, I guess, our yards. And now we're just going to say 30 times 3 equals 90 feet. If we were going to convert 30, let me scoot this up, 30 feet, 30 feet 2 yards, let's say 30 feet over 1, and we're converting, or we want to put feet on the bottom on this side. So 3 feet, what does that convert to? 1 yard. All right, now we're going to cross cancel our feet here. There's feet there and there, we can cancel those out. 30 times 1 is 30. And we have yards left over. So our answer is 30 yards. Oh, wait, I'm sorry. Over 3. What do we do with this 3? It gives us 10 yards when we reduce that down. I do not have practice problems for you on this. But I do want you to go to page 563 and do the practice problems A through G. You only have to work out, you only have to show your work for E, F, and G, but I would like for you to do A through D in your head. Okay, just read through them and figure out what the answers are, and then do E, F, and G, and put that on the top of your math problem set, 116. And we're good to go. See y'all next week. Bye.